Hello everyone, welcome to LICD Lecture 3B. Today's topic is non-inverting amplifier analysis using virtual short method. So this is my non-inverting amplifier with a negative feedback. The input is applied to the non-inverting terminal and we will derive its expression of output voltage gain with the help of virtual sort method. So let us try to understand what is virtual sort. So virtual sort, we have V plus. First condition is V plus is approximately equal to V minus, and the second condition is I plus and I minus, that is the current flowing into the op-amp terminals is almost equal to 0. So let us start our analysis. Let me select the color of my pen as orange. Okay, so let me start. So here, let me mark over here V plus and V minus. So here, this is my V plus and this is my V minus terminal. So what we can see, this current, this voltage V in reaches this V plus terminal. Since there is no input terminal, no input current flowing through the op-amp, this I plus is equal to 0. So this voltage here will reach V in will reach V plus terminal. So this is my step number 1. Second step is, from virtual sort concept, we know that V plus is approximately equal to V minus. So hence second step will be your V minus will be equal to, this is my second step, my V minus will be equal to V in. So this will become as V in. So V in terminal will reach over here. Now, next, this V in will reach this point. It is because it is connected to a wire. So this is my V in reaching this point. So this becomes my V in. So this is my step number 3. Okay, and also no current flows into the op-amp. So no I minus is also 0. So now next step is, this V in is over here. So let us say what will be the current flowing through this. Let me just take this, V out term a little that side. Let me just extend this terminal out a little. Okay, so that will help a lot. Okay, so let me select the color as orange now. Okay, fine. So the step number 3 is, this V minus will reach this point. So this is my V in. So if this is V in, what will be my current over here? Current flowing through R1 will be V in divided by R1. Okay, so this is what my expression is. Now, this current flowing over here, that is current flowing through R1. What will be my current in from here? Let me mark it in the red. So what will be my current here? So as we know that the current flowing into the op-amp terminal I minus is 0. So we can say that this current over here I minus is also 0. That means that the current which is flowing into the resistor R1 and into the resistor R2 must be same, because this current V in upon R1 should come from R2. It should not come from the left hand side, that is I minus is 0, because so the same current will flow along this terminal also. So this is my step number. So this will be my step number 4. My step number 5 is that I minus is 0. So this will lead to, now this will lead to something else. So this current, same current flows through resistor R2. So the current here will be V in upon R2. So sorry, it will be divided by R1. Sorry. So current flowing through R2 will be V in divided by R1. Now, so this will be my step number 5. So what is the voltage drop across this R2? So let me just write, V out is equal to voltage drop across R2 plus voltage drop across R1. Now voltage drop across R1 is nothing but V in. So this will be V in. Okay, so what will be VR2? So VR2 will be the voltage drop across R2 will be the current flowing through it and multiplied by resistor. So it is V in into R2 divided by R1. So this will be V in into R2 divided by R1. So when we club both the terms together, see what we will get. So we will get V out is equal to 1 plus R2 upon R1 into V in. So that's it. This is my expression of my output voltage for a. So if I take V in that side, it will become a voltage gain. So this is the same expression. So we can take this V in out in the next step. So this is my final expression over here. So V out divided by V in is equal to 1 plus R2 upon R1. So this is my expression for gain for a non-inverting amplifier using virtual short technique. So see how easy it is to analyze this using virtual short technique. Just few steps and that's it. So that's how we analyze circuits using virtual short method. So that's it for today's topic. Next time we'll do the same analysis, that is virtual short analysis for an inverting amplifier. So until then, have a good day.